Hello children, welcome to channel Sube. Children, today I am going to discuss question number 4 from the MCQ part of 2021 Physics new syllabus paper. If no external forces act on a system, which of the following is conserved in any type of collision? First one, total kinetic energy. Second one, total potential energy. Third one, total mechanical energy. Fourth one, total angular velocity. Fifth one, total linear momentum. So in this question they say any type of collision. That means there must be several types of collisions. So if we consider what are these collisions can be divided into two categories. One is called inelastic collisions and the other is called elastic collisions. So if we explained what are they in simple words, say we allowed a rubber ball to fall freely to the ground, and what happens, it moves down, and just before the collision with the ground, say the speed is v, and as soon as the collision, after the collision, if we measure the speed, if it is equal to the same speed, that means if it bounds with a velocity v, not velocity actually, speed, we can't say velocities are equal because the direction is opposite here, so velocity must have been changed. The speed, if the speed is same as soon as it bounds off, so that means the kinetic energy before the collision is equal to the kinetic energy after collision. So that means no kinetic energy is converted into heat or sound or any other energy. So that sort of if this collision fulfill that condition, that means if the kinetic energies are equal, so that sort of collisions are called elastic collisions. So if these kinetic energies are not equal, sometimes after the collision the kinetic energy may be zero, so that sort of collisions are called inelastic collisions. So there are regarding this inelastic collisions, there are some collisions that are perfectly inelastic. So there is a special condition, perfectly inelastic collisions are there. That means as I said, if the velocity after the collision is zero, that means the initial kinetic energy, the total initial kinetic energy has been totally converted into other energies. So that means that sort of collisions, inelastic collisions, are called perfectly inelastic collisions. So examples for such a collision is a wet mud ball. If we throw a wet mud ball to a wall and if it sticks there without falling, so that sort of collisions are called perfectly inelastic collisions. Sometimes we say totally inelastic collisions. And also if it is an elastic collision, not only the kinetic energy is conserved, collision in which both momentum and kinetic energy are conserved. So if both momentum and kinetic energies are conserved, that collision is called an elastic collision. So therefore now we can just write a note like this. We can apply these two laws to elastic collisions, these both laws to elastic collisions, but the law of conservation of momentum can be applied to the both types of collisions. Both types of collisions we can apply the law of conservation of momentum. So we can write the note like this. So here, if it is an elastic collision, we can apply these both laws, and if it is an inelastic collision, we can apply only conservation of momentum. So now we have solved the problem actually, because in the question what they ask is, if no external forces act on a system, which of the following is conserved in any type of collisions? That means in both collisions, what is the law that we can apply? That is what they ask. So for these both types of collisions, this momentum, linear momentum, conservation of linear momentum or the total momentum is constant. So total linear momentum is conserved. Here they ask which of the following is conserved. So total linear momentum is conserved according to the lesson. So we don't have to do any arguments, or don't have to do any calculations. If you remember the lesson, it's like this. So here you see the both sides have this law. That means we can apply it. So this one is the answer. The fifth one is the answer. So examples for elastic collisions is an example is the collision between two billiard balls. So that is the example that they have given to us, which is totally elastic. So we have to write this example if they ask in the exam, and this example if they ask in the exam for inelastic collisions. So now let us see how we apply these laws in two types of questions, calculations. Let us take first an problem in inelastic collision, and later let us solve a problem in elastic collision. So now let us try to solve this problem. A 4 kg ball moves with a speed 2 ms minus 1 and collides with a 3 kg ball which is at rest, and it sticks together. What is the speed of them? So let us draw a little diagram to illustrate. So this one is the 4 kg ball, and this one is the 3 kg ball, assume like that. So after the collision, they stick together and moves together like this. Then let us mark these values. This one 4 kg. Let us write here. The speed 2 ms minus 1. This one at rest, that means velocity equals 0. 3 kg. Then total 7 kg. 4, 6, 7. 4, 5, 6, 7. 7 kg. So the velocity we don't know, that is what they ask. So say it is x. After collision, the compound moves at a velocity, speed, just say speed x. So this diagram is before the collision. This part of the diagram is before the collision, and this part is after the collision. So since these balls stick together after the collision, so this must be a inelastic collision, because we explained that if a wet mud ball, if we throw it to the wall and if it sticks there, so that type of a collision is inelastic. So therefore we have to assume that it is not given in the question, but since the balls are stuck together, we have to assume that the collision is an inelastic collision. Therefore, we can apply only this theory, because we are now in this side, only the conservation of linear momentum. We can't apply the conservation of kinetic energy because it is not elastic. If it were elastic, we would have applied. So now we can write linear conservation of linear momentum. That means we have to take the mv terms for each objects. So mv term of this one, then mv term of this one equals to the mv term of this complex. So that means the conservation means, what is the meaning of conservation? Equals. In simple word we say equals. So let us write m here. What is m? 4 times then velocity 2 plus, here m is 3 but the velocity is 0, so total it is 0. So here total mass 7 kilogram times velocity is x. So 4 times 2 8, so this one is 0, so we don't have to write it, equal 7x. So x equals 8 divided by 7. So the answer is 1.14 ms minus 1. So like that easily we can solve the problem if it is inelastic collision. So let us try to solve another problem which is an elastic collision. So now I will show you how to solve a problem regarding this elastic collisions. So let us take this question. A 4 kilogram ball moves with a speed 5 ms minus 1 and collides with a 2 kilogram ball which is at rest. If the collision is an elastic collision, what will be the speed of them after the collision? Then let us as usually draw a little diagram. This one is, these are the balls, and after the collision they separately move. So like this. So 4 kilogram, this one 2 kilogram, then same. So velocity is 4 kilogram ball moves with a speed 5 and collides with the 2 kilogram ball which is at rest. This one is 0. Then after the collision, what would be the speed? That is what they want us to find. So we don't know, therefore we assume the speed of this after the collision is x. So the speed of this ball after the collision is y. So let us assume like that. So here there are two variables, we don't know, but here it was only one variable, so therefore it was easier. Now here it is a little bit difficult, actually not little bit, it is actually difficult. So however there is a method, so if you know the method it is not difficult actually. If you remember the method it is easier. So children, first of all we can write the equation that we used in this early calculation. This one always can be used for both the collisions. Whatever the collisions we can use this equation, because the theory is like that. For both collisions we can use it, so therefore no problem. Without considering whether it is an elastic or inelastic collisions, we can start writing the conservation of linear momentum law. Conservation of linear momentum law. So that means we have to write mv parts, mv terms. So what is the mv term here? 4 times 5, and here since the velocity is 0, we don't have to write because 2 times 0 is 0. Then equals here 4 times x plus here 2 times y, then 2y, like this. So here 4 times 5 is 20, then 4 times x plus 2 times y. So we can simplify, we can divide by 2, then we get 10, then 2x plus y. So let us stop here for a moment. Now since it is an elastic collision, we can write another equation. So this one, because we are now in this side, the collision is an elastic one. So already we have written this equation. So now we are going to write this equation, conservation of kinetic energy. What is that? We have to write kinetic energies, the terms kinetic energy terms. Kinetic energy equals what? Half mv squared. So that half mv squared term we have to write for each, before and after collision separately. We have to write and equate them. So let us do it now. So kinetic energy, conservation of kinetic energy. Conservation of kinetic energy is the topic. So what is half mv squared? M is 4 kilogram, v squared, v means 5 times 5 is 25, plus then this one is going to be 0 because the velocity is 0, therefore we don't have to write, equals. So after the collision, the total one we have to take. The first, let us take this one. Half m is 4, then v squared is x squared, plus again half this one 2 y squared. So this is the equation. So what we have to do now? Simplify. So let us cancel half, then 4 times 25 is 100, equals 4x squared plus 2y squared. So we can divide by 2, then 50 equals 2x squared plus just y squared. I have to save the video from time to time because otherwise it is get stuck. So now what we have to do, there are two equations here, 1 and this one 2. Two variables we don't know, x we don't know, y here also x and y we don't know. Therefore that is why we have used these two laws, conservation of energy, kinetic energy, and conservation of linear momentum. So now we have to remove one variable using our common knowledge, algebra. So here you can see x squared is there. So we can substitute x from this equation. So therefore before that we have to isolate x from this equation. Let us write 2x first of all. 2x equals what? 10 minus y, yeah? Then x equals 10 minus y, the total thing divided by 2. So we get x equals 10 by 2 is 5 minus y divided by 2. Then let us substitute this one to this place, x squared. Now before that let us take the square value of this, and then is here is square. To do x square I have to remind you, a minus b squared is what? A squared minus 2 times ab, then plus b squared. You remember? That knowledge we need now. So let us take some let us take it here, otherwise we will not have enough room. So keep it here by the side and let us use blue color for that. So x squared what we need, then this one is going to be a, this one is going to be b. So a squared, then 5 times 5, 25, minus 2ab. 2 times a is 10, then 10 multiplied by this one, be divided by 2 means 5y. Okay, 2 times a times b. So 2 times 5 is 10, 10 times y divided by 2 means 5 times y, but the sign is minus. Then minus positive, then y squared divided by 2 squared is what, 4. So totally this thing, so we have to substitute it here. So let us take these people a little bit here, then let us substitute that to where, to this place, x squared is there. So 50 equals 2 times this man 25 minus 5y plus y squared by 4. Then when you write this y squared, you forget this one normally, because already we have written something like y squared. Don't forget that, plus y squared again. Normally you might miss it, so this one is this one. So now you have to, I have to say over. So now let us continue. You have to simplify, you have to remove the brackets. 50 equals 2 times 25 is 50 minus 10y plus 2 divided by 4 means y squared divided by 2 plus y squared, this one. Okay, 2 times 25, 10 minus plus y squared divided by 2. So these people cancel. So 0 equals minus 10y plus half y squared plus 1 y squared, then 1 half y squared, that means 2 times 1 is 2 plus 1 is 3 divided by 2, 3 divided by 2 y squared. So we take this man this to this side, so 10y equals 3 divided by 2 y squared. So 1 y cancel, then y equals 10 times 2 divided by 3, then y squared, y equals 20 divided by 3. So this one is the answer. So children, we know y equals 20 divided by 3. So let us write it at the diagram. This one we have found 20 divided by 3, that is the value. So now we have to find out this x. So how to do that? Here earlier previously we have derived a certain equation, easy one. Let us use this one, x equals 5 minus y divided by 2. So let us take it down here, and we are going to now find x using this one. So x equals 5 minus y divided by 2. So y is 20 divided by 3. So then this 2 goes to the denominator like this. Then x equals 5 minus 20 divided by 3 times 2 is 6. Then we can take 6 here, then 30 here, here 1 times 6 times 5, 30 minus 6 times 1, then 20. Then here 30 minus 20 is 10 divided by 6, but here something divided by 3 we have taken, therefore we have to convert this into the same way. Then 5 divided by 3, x equals that. So let us write that also close to the variable x, 5 divided by 3. Now we have calculated the values according to the theories, two theories. So now we can check whether these values that already we have found are correct. This is how it should be done. So I copy this to somewhere there a room. Let us take it here. Now we can check, checking. You don't have to do all these things in the for the multiple choice MCQs. You can't spend this much of time, but I am teaching. If you like, you can do. So checking, check. What we are going to check is whether these values are going with those rules, matching those rules. The first rule, what is the first rule? The total MV value of this side must be the total MV value of this side. So now we know these values, velocities we know, you can find it. So here let us write then 4 times 5, m is 4, speed 5, then 20, what are the units? MV, m is kilogram, v is meter per second, kilogram, ms minus 1, 20 we get at the left side. So here 4 times 5 divided by 3, that means 20 divided by 3, and here 2 times 20 divided by 3, then 40 divided by 3, the total, the denominator is same, then 60 divided by 3 equals 20. Okay, we are correct. That is how we check. Not only that, we can check kinetic energy, then half mv squared term we have to check. Here half m is 4, then v squared, v is 5 times 5 is 25, the left side is that. Then 100 divided by 2 is 50. What is the unit? Joule, because kinetic energy, we have found kinetic energy. So that is one, that is what we get from the left side. So here half m is this one, 4 velocity, 5 divided by 3 squared, then cancel, then 2, 4 divided by 2 is 2, then 5 times 5 25, 3 times 3 9, then 25 times 2 50 divided by 9. Let us keep it here for a moment. Then here the next object, half 2, half times 2, mass is 2, velocity this one 20 by 3, the square value of that man, then 2 to cancel, 20 times 20 is 400, then 3 times 3 is 9. So we have to add these two, plus 400 divided by 9, so 450 divided by 9, then 245, how many times? 5 times, then 0, joule, high, correct, equals, correct. So our calculation is successful. So these types of this one is a little bit not little bit difficult, but if you practiced it, it is not difficult. The same way you have to go. the same way you have to at least do 20 questions, 20 problems we have to solve at least. If you do 50 or 100, then very good, you can easily pass. If you are lucky, you get the same type of question in the exam. So there is another method, I will explain that also. That method is good for only MCQ, but you can't use for that essay papers. That method is not in your syllabus, that is why. So I will show that also. So let us try to use that short method, but you can't use it in essay papers. So it is like this. First you have to you can't neglect this first step here. The first equation you have to write, however, but the second one, that kinetic part, you can neglect, you can avoid like this. So there is a method. You have to write, say the velocity of this one is v1, velocity of this one is v2. After the collision, velocity of this one is v1 dash. After the collision, this one, velocity of this one is v2 dash. We write dash for after collision. So the equation is without using mass, because this equation has been derived by that original equation, so no problem. So we write the first velocity of the first ball plus the second velocity of the first ball equals the first velocity of the second ball plus the second velocity of the second velocity of the second velocity of the second ball, like this. So we have to substitute now. The first velocity of first ball is 5 plus the second velocity of the first ball we don't know, that is x. I will keep aside this, already we found these things, so aside, keep it aside like this, the same order, we can check later. So the problem is x and y we don't know there. So here x, the second velocity of first ball, x, then equals the first velocity of the second ball, this one 0 plus second ball second velocity, so this one second ball second velocity is y. You don't have to use mass, so that is therefore easier. So now simplify. 5 plus x equals y, then 5 equals minus x plus y. We write it like this, xy shape. So this one is the first one. No, this one is the second one. Already we have a first one. First one is this equation. We have taken that from this linear momentum, conservation of linear momentum. So let us copy it and take down. So this equation we now keep here to compare, and we have to do something so that we can eliminate x. So here 2x is here, so minus and positive. Then if we get 2x, however, here we can cancel each other if we add these two equations. So therefore let us keep this here, and let us do what? Multiply by 2, then we can get 2x. Then 10 equals minus 2 times x plus 2 times y. Right, now let us simplify, keep it here, a little bit here. Then what we do? Add these equations to, what is our goal? To cancel x. So when we multiply, what happens? These people add together, then come to 20, then these people cancel each other, so equals 2y plus y, 3y. Then y equals 2 divided by 3. Very easy, no? 2 divided by 3, the same here. Y equals 2 divided by 3, the same answer. 20 divided by 3 here. 20 by 3. So the same way you have to find out, substitute into this equation. Or you can use this one. Or you can use already what we have, this one, but without cancelling. That 2 here, keep it here, and we can't cancel like this now. So 10 equals minus 2x plus 2 times y is this one, 20 divided by 3. Then 10 equals minus 2x plus 40 divided by 3. I have to save. So 10, let us isolate 2x, let's take 2 left side, 2x, then it becomes positive, then 40 divided by 3 minus 10, we took 10 to this right side, this one to left side, this one to right side, 40 divided by 3 as it is. Then 2x equals, let us take 3 as the common denominator, then 1 times 40 minus here 1, then 1 times 3, then 30. So 2x equals 40 minus 30 is 10 divided by 3. So x equals 5 divided by 3. We took this one and cancel 5. So like that. 5 divided by 3. 5 divided by 3. Here 5 divided by 3. But we received earlier this one. 5 divided by 3 equal. Right. The both methods. Now we finished. But this one is easier, you see. Earlier we used a page like this. I deleted it. So in very small steps we found the answer. So that is very good for MCQ questions. So children, I think you are happy. I spent a lot of time to do this, you see. So I think you understood. I think you are happy. So I will be happy if you subscribe my channel before you go. So see you tomorrow. Goodbye.